Alright, so the next section is on rotations. Okay, or it's just like it turns. So if you think of like a game, like a board game, like a spinner on a board game, like when you flick it, the thing turns and spins around until it reaches a certain, space on the spinner. So that would be like a rotation. So you can do rotations around like any kind of point on a graph, which can become kind of difficult. So the only rotations that we're going to do are going to be like rotating around the origin of the graph. Okay, and so here's kind of a big thing to like work on. So the words they use, they say it's a rotation about the origin. So we're going to have a 90-degree rotation, which would be like a quarter of a turn. I think everybody, a 90-degree angle is like an L. We'll do 180 degrees and 270 degrees. So they're in 90-degree increments. Okay, so if we start with whatever point we start with, and then you do a rotation that's 90 degrees, okay, the new coordinate is like the x become, like whatever the x number was becomes the y number, and the y number becomes the x number but negative, or the opposite sign. I'll show you what that means in a minute. 180 degrees, everything stays the same, just opposite. So the x is still the x, but just the opposite. If it was positive, make it negative. If it was negative, make it positive. And 270 is kind of the opposite of the first one. The x becomes the y becomes the x, but instead of the y being like opposite, the x turns to the opposite. Okay, so really each, like, so I'm not going to put necessarily like a coordinate here, but well, I can, let's see. So if I put the coordinate 3, 2. Okay, and so if I apply this 90-degree rotation, okay, so for like 90 degrees, the x becomes the y part, and the y becomes the x but negative. So if I go -2, +3. And so really what it's doing, if the graph, like if you have graph paper, this would work perfect, but it's saying if I go to the origin and then I go to the point, I would have a 90-degree angle right there. Okay, so you don't have to like draw that in or anything, but just kind of a visual for what's going on. Okay, so if we did 180 degrees, they're just both opposite. So -3, -2. -3, -2. And on 180 degrees, you should be able to draw a line right through the middle and hit the other point if you did it correctly. Okay, and then for 270, okay, again we switch the 2, but the x number, so the 3 becomes negative. So 2 to the right and down 3 for that one. Okay, and if you do it right, you won't have to do them necessarily, like you only have to do one rotation. But like if you did each like 90, 180, 270, you notice it makes a square if you connect all the dots, and that should happen. Okay, but again, you'll just have to do just 180 or just 90 or just 270. Okay, but the other thing I want you to notice is, number one, we're rotating this way. That always happens, so what would be considered counterclockwise, and we have tons of digital clocks out there, but a regular clock, like clockwise, would be considered going the other way, going like to the right. Counterclockwise goes to the left. But each quadrant, so each like space, is 90 degrees. So on that one, we started over here, and then the 90-degree rotation went there, and then 180 degrees went there, and then 270 went there. Okay, if you started up here somewhere, then 90 degrees would be in that quadrant, 180 would be there, and 270 would be there. So it's a way, if you can kind of get that part of things, you know, like memorized, it's a way to at least check your answers. So when you do a problem, you know, it should go one like quadrant. Okay, if the point happens to be on an axis, 90 degrees is the other axis. So if it started on the y-axis here, then 90 degrees is going to be over there, and 180 is going to be over there, and 270 is going to be, you know, you're going to touch the other axis. Okay, so that's a big, like this is really important to remember, because many of your problems are going to talk about rotating about the origin. So that's a huge thing to remember. Okay, 90 degrees, switch them, and the y is negative. 180 degrees, just make both of them opposite. 270, switch them, but the x part, the number, becomes negative when you switch it. All right. That you study that box. That's going to be the biggest like help for you. And if you do the problems and you write the coordinates out, I think you'll be well on your way to actually memorizing it. Okay? All right. So that's all I got. You'll have a quiz on Friday over sections 1, 2, and 3. So we did section 3. I'm going to wait till Friday to do the quiz, though. Okay, so we will talk about the next section tomorrow, but it will not be on the quiz. All right, have a great rest of your day, guys. We'll see you tomorrow. So, you know, really, I just work with like the coordinates. So, versus, sorry, I had something on my screen, versus trying to like graph it like with 90 degrees or anything like that. Okay, so if we had 3, 1, 5, 1, 5, negative 3, and 2, negative 1. So 3, 1, 5, 1, 5, negative 3, and 2, negative 1. So if we did like A, B, C, and D. And we were supposed to do a rotation of 270 degrees. Okay, so remember if you kind of go back to the last slide, when we do 270, we're going to switch them, but then the x number 3, when we switch it, becomes negative. So we're going to switch them, but we do the opposite of the x number. We're going to switch them and do the opposite of the x number. Okay, so make sure that those negatives for the y numbers still stay like negative when you switch them. Okay, so there's our new points. So if you remember, each quadrant, this one's kind of different because it has some in this top quadrant, quadrant number 1, and it goes counterclockwise. So D and C are in quadrant 4. So D and C, or A and B should go 1, 2, 3, and end up where the D and the C are. And the D and the C should go 1, 2, 3, and end up to the quadrant to the left. So 1, negative 3, 1, negative 5. So that's our new A prime, B prime. Negative 3, negative 5. So that would be C prime. And negative 1, negative 2, that would be the D prime. Okay, so you can kind of see the A and the B are one spot above that line, and as you rotate it, the A and the B for A prime and B prime are one spot to the right, but that's because of the rotation part. Okay, they're going to be kind of the same distance, if you will, from an axis. So the D is one spot below, it's one spot to the left. Okay, so you'll have to do a few graphing ones for sure. All right. Okay. So one of the other things you'll have to do is a composition. And a composition is going to be a rotation and something else that we've already talked about. So we talked about translations and we've talked about reflections. So it's going to be a rotation combined with one of those. Okay, so let's say we had 1, negative 3, 2, negative 6, and 3, negative 4. And then we were supposed to do a reflection in the y-axis and a rotation of 90 degrees. Okay, so these can get tricky sometimes, and we'll see if it happens on this one. So 1, -3, 2, -6, and 3, -4. Okay, so if we add our A, B, and C. Alright, so reflection in the y-axis means flip them over here. So the A is 1 space away, the B is 3 spaces away, and the C is 2 spaces away. Okay. Now, you don't technically have to, but it's the best option. I would write down these the new coordinates. So the A prime is -1, -3. The B prime is -3, and -4. And the C prime is -2, -6. Okay, so the reason that I write them down like that is because now if I'm going to do a 90-degree rotation, I'm going to switch them. Okay, but on this one, the y part, when it becomes the x part, you do the opposite. So I'm going to do +3. So I switch them, but the new x becomes positive, and I switch them, and that one becomes positive. So I get 3, -1, 4, -1, 2, 3, and 6, -2. So here's our A double prime, B double prime, and C double prime. So it didn't happen on this one, but sometimes like they overlap. You know, like the B point ends up in the middle of the original triangle or something weird like that. So hopefully if that does happen, you know, it's, you know, can get confusing, but if you happen to have different colors to write with, like, fantastic. If not, that's okay. All right. So most of your assignment will be stuff like that. And then the last bit of your assignment, it's going to talk about rotational symmetry. So symmetry means like the same thing. So we didn't really talk about it yesterday, but like if I had a rectangle and if I did like line symmetry, if I drew a line, it's supposed to be a little bit closer to down the middle, but like if I folded it, it would match. You know, so if you fold a piece of paper in half, it just makes it be half the size of the piece of paper. So, and it would like match up to where you wouldn't be able to tell like if there was any like things sticking out. Okay, so you could draw a line through the middle and fold it like long ways and it would match up. You could not do it diagonally. If you don't believe me, take a piece of paper and try to fold it diagonally. It will not match up perfect. Okay, so that's what's considered line symmetry. It's kind of like a reflection. So there was a little bit of in the section yesterday on reflections about line symmetry, but I kind of wanted to talk about the two together. So line symmetry is like a reflection. If I reflect this point over there, it'll match. If I reflect this point over there, it'll match. Rotational symmetry means we're going to turn it, and is it going to match? So let's see if I can draw this good. Let's pretend that all those are like perfect. So if you were to, kind of put a center like piece in here and you spun it, how many times will it match? And so in a figure where kind of everything's the same on the top, bottom, right, and left, like this is, you can essentially just count the sides. Like, so if we were to rotate, this side one, like once, it would end up over here where there's 2, 3, 4, 5, 6, 7, 8. So it'll match 8 times, including going all the way back up to the beginning. So if I do that, 360 divided by 8 is 45 degrees. So an octagon would every 45 degrees it will match. So 45 degrees, 90 degrees, 135 degrees, 180 degrees, and you could keep like adding 45. But most of the time the book just stops at 180. Okay, and I'll talk about why that is in just a second. So if you had a parallelogram, well, if I kind of put something in the center there, it's not the same in all 4 directions. So I can't just say, well, there's 4 sides, because like this, if I drew a line like to that corner and to that corner, like they're different lengths. So I can't just say, well, there's 4 sides, do 360 divided by 4. So the divide by 360 works if kind of like everything's the same on every like direction. So for this one, it's kind of like, okay, where, if I spin it, where's it going to match? Okay, and so as I spin it, like when this corner gets over here, it will match. And then if I keep spinning it, it'll match again when we get back to the beginning. So this one, how many times will it match? It'll match twice. So this one would just have what would be considered 180 degrees rotational symmetry. Okay, if it doesn't match at all until it gets all the way back around, it doesn't have any symmetry. So if we were to do a trapezoid, now it has line symmetry. If I drew a line down the middle, it would fold over. So it would have line symmetry, but rotational symmetry, it wouldn't match up when you spun it until it got all the way back to the beginning. So we would say that this one has no rotational symmetry because it has to go all the way back around. Okay, so you'll have 4 pictures that just says determine whether the figure has rotational symmetry. If so, describe any rotations that map the figure onto itself. So it's going to use this word map, which essentially just means match. When it matches, it lays on top of itself. Okay, and so on those ones, it wants you to list every degree that it's possible, but less than 180 degrees. So you can stop once you get to a number that's 180 or more. Okay, and then it'll have 4 where it's kind of like a matching. So it'll say select the angles of rotational symmetry for each regular polygon. Regular means everything's the same, the sides and the angles. Select all that apply. So it's the same thing. How many times will it rotate, but it's under 180? So there could be one answer, there could be 2 answers, there could be 3 answers. It just depends on the shape. Okay, so really go back and make sure